This is, I think it's chapter 3 in the book, and it's talking about tanks and tank storage. I will say the maximum tank size you can store inside a building is how much? 660. 660. That's for one tank. So what if I want more than that? What do I do? Two tanks, which equals to what? 1320. And that's 1320 for two tanks inside a building. The maximum that you can store in any building is you can have a big storage tank. And how much is that?
10,000.
10,000. So remember those three numbers. There are at least 2 or 3 questions about that in the exam, at least when I took it.
For the oil burner?
Yeah, and they try to confuse you a little bit. So if they say the maximum size tank and they put 1,300, read the question carefully. That's correct. That's incorrect. For each tank, inside has to be 660. If you want more than that, 2 tanks. The maximum amount of at any building is 10,000 gallons.
Commercial and residential?
In the
Huh?
ground,
Yeah,
In the ground.
in the,
only,
in the ground. Yeah.
not above.
If it's 10,000, it has to be underground. Yeah. This is some of the, again, which one is bigger, vent pipe or fill pipe? Vent pipe is bigger. Which one is higher, vent pipe or fill pipe?
Actually, no.
Vent pipes.
Vent pipe is higher, and I showed you outside the class, it was a little bit higher. So these things a little bit, it's good to understand. And always you want the tank to be a little bit in the same level as the burner, to use gravity feed. If it's much lower, it's going to be probably difficult to pull oil out of that. Okay. So NFPA, fill pipe must, vent and fill pipe must terminate outside the building at least 5 feet from any building opening.
I thought it was 2.
That's for the vent, that's for NFPA. So NFPA standards are either higher than the local. For mass users, 2 feet from any opening, NFPA require 5 feet.
Mass is 2 feet, but.
2 feet. NFPA.
So which one do we follow, this one?
Well, if you're installing a mass use, it's going to be 2 feet.
Oh, okay, so this is the national.
Yeah.
Okay, so we have to
So
find.
that's an amendment to the NFPA, a mass amendment to the NFPA.
So we talked about codes before, and the national codes is going to be the minimum. State codes is going to be higher than the national. City code could be higher than the state. So NFPA require 5 feet. Massachusetts CMR require 2 feet from any opening. The fill vent should not be smaller than the fill pipe. It could be equal. That's according to NFPA. For CMR, they want it to be a little bit bigger. So the minimum, at least equal, not smaller. Equal is acceptable. The state want it to be bigger. So think about the logic behind that. You're filling liquid very quick. Gas is expandable. So you want it to have more opening to go through. So try to remember those little tidbits. Both vent and fill opening must have weatherproof caps to prevent tampering and water intake. So they should be sealed with a lock, weatherproof cap, so it will not get filled. And if they terminate on ground, they should be sticking out with some kind of perimeter, so nobody will go mow the grass and hit the pipe. And you don't want stuff to fall into it. You don't want insects to go build nests inside of it. And you don't want somebody to just come and tamper with it and fill some water or whatever. And again, it rains a lot in here, so you want something to be weather protected. Fill and vent pipe should be iron, steel, Schedule 40 brass pipe, or Schedule 40 is very thick brass pipe, brass, not copper. What is brass? Brass is copper and nickel.
Yeah.
It's yellow color, it's an alloy. So that is NFPA requirement. Steel is very common because it's strong and can handle the bending. Again, it's going to be outside, it's going to be subject to some kind of bending or mechanical damage. So you want something that will be able to stand the impacts. Cast iron fitting are not to be used. So you don't use cast iron fittings for that pipe.
For the underground?
Yeah. because they are more susceptible to rust. So it's just stuff you have to remember. And if you know a little bit the logic behind that, it will help you remember. So no cast iron fitting are to be used because they are susceptible to rust. And fitting usually is where you have a lot of rust. Vent pipe or 660-gallon tank must be at least 1.5 foot higher than the fill pipe. So that's for the 660 tank. Should be a little bit higher than the fill pipe. And we saw that outside, right? So remember the picture? Remember what we saw outside when we looked?
I thought that was wrong.
Huh?
I thought that
It was higher.
Oh, it was higher. It was
Yeah.
Same size. pipe.
Same size, yeah, which is the minimum. But again, it was higher, much higher, at least 4.5 above the fill. In case that you overfill, does not spill on the vent pipe. Okay? Good?
Yeah, I was gonna ask you, when we're studying for our oil burner's license, do we need to know national code as well as obviously state code?
Yeah. If they, whatever's in the book, should be like in the CMR. That will use some of that, and sometimes not even that. So 15 question for what I remember was basic electricity, which is not in the book. The book, we usually talk about the tank, storage, and pipe. But I don't think they will ask you about the NFPA, they want you to know the state code. And again, the Massachusetts oil burner license applies only in Massachusetts. I don't think you need the same license in Connecticut or in New Hampshire. So this is for the in-state. I will do some of the review questions. I have, I think, 200 questions in the question bank, so we'll go over these in a while. So more piping regulation. When the tank is higher than the burner, an anti-siphoning valve must be installed. So in the case where you could not bury the tank, you have a big tank, let's say you could not bury it, so it happened that the tank is bigger than the burner. So what are you gonna do? You're gonna put an anti-siphoning device. And if the tank is completely empty, probably you're gonna pull some air into it and you have to refill the pipe. So that's something you have to keep in mind. If the tank is at the same level, you need some kind of anti-siphoning valve to prevent the fluid from going back to the tank and to have some kind of air intake. It's kind of the same thing that you have
If
in
the
your...
tank is higher, how can the fluid go back to the tank?
Huh?
If the tank is higher than the burner?
No, if the tank is higher, you might be able to like suck in air if it's empty.
Oh, okay.
Yeah.
Oh, I see.
Thermal valve must be installed in the suction line before the filter. So thermal valve is kind of the firematic, but this time it stops oil, not current. And it also opens at 165 degrees. So before the filter, you should install the firematic valve.
Melt,
or valve,
the
not
melt
switch.
away, the melt away
Yeah.
mechanical one.
Yeah. So remember that. Before the filter, at 165 degrees, you must have a firematic valve. How does it work again?
You say before the filter, before,
Coming out of the tank before the filter.
okay.
How does it work? At 165, it will melt and drop the stem, the fluid, so the more flow will be coming out. Just in case it gets, there's a fire, something of that sort.
That's the solenoid valve, right?
Yeah,
No.
it's not a solenoid valve, it's mostly a firematic valve. So the ones in the board, where the stem is up?
The other class we did the four part the oil burner.
Yeah. So it has a stem, and it has some kind of lid, and it will just like melt and shut off the,
It looks like it's made out of lead or something.
yeah. Tank failure. So consider the average lifespan of the tank. So depending on the manufacturer, some tank has been there forever. They are very thin. So at some point, if you are going to do a service or an install, you might want to recommend replacing the tank. They get very thin, they get very old. And usually, where does the water accumulate in the tank? In the bottom. That's when you see some rust. So investigate and inspect the legs very carefully. Location, the tank failure depends on the location, thickness, is it buried or above ground? So once a year, it's not a bad idea. Actually, it's part of your inspection to go on and walk around the tank, look at the construction. Is it flimsy? Are there some leak? I've seen some really quick fix on tanks. Something look like duct tape or some kind of magnets you put to stop a leak. So this is stuff you don't want to do, and you can say I cannot work on this and put my name on it unless you replace the tank. And tanks are not that expensive. You can get a brand new fiberglass tank for around between 300 and 600. But again, the tank is holding a lot of liquid in it, and you understand that it might not leak when it's half full or quarter filled. But if it completely filled, the pressure will cause the tank to leak more. And how do you find leaks? Usually visually is enough. You can go around the tank and see where you have some kind of condensation or dew. It's easy to see the leaks. I mean, in your car engine, if you open the hood, you know where the leak is, unless it's everywhere. And what do you do? The first thing you do when you want to find where the leak is, if it looks like oil everywhere, what are you gonna do?
Wash it down.
Yeah, you wash the car and then try to inspect and see where the oil is coming from. Sometimes low quality steel can lead to tank leak. Again, the price does make a difference here. And some of them are not really painted or coated, so over time they will rust. If you bury the tank in acidic soil, or you bury the tank and you have some kind of fertilizers that you put in the grass, over time you do not pay attention to it, it might eventually corrode and leak. Water in the soil will cause the tank to deteriorate over time, especially if it's buried. That's why buried tanks are more expensive. Tank is dented or mishandled, so whenever you dent the tank, the possibility of it to leak is very high. So investigate that, look around the tank. Why? What happened when the tank is dented? You have changed the structure of the metal inside. It's kind of how they tell you don't buy canned food if the can is dented. So you have break the liner inside, you mushed it around, and then a lot of metallic thing will dissolve into food, and in this case it will dissolve into the tank. Alright. Tank and product also is water. So every season you want to go and check for water, and I'll show you how you check for water. What do we use?
Oh, we use, yeah, that.
Stick with the chemical. and-
Stick with the paste. The paste you buy from the hardware store, you put it in a stick and drop it from the top, and it will change color if there's water.
Do you put it in where the plug is or from outside?
I know there's a plug.
Yeah.
You have to drop it inside the water. So water will cause the product to deteriorate faster, and water will also promote the growth of sludge. So you want to be careful with that. Any question about tank failure? What would cause tank failure?
Oh, you had on one of the notes, average lifespan, what was that?
Yeah.
It depends on the tank, but usually between 10 and 20 years. Usually they don't give you more than 10, depending. So again, that lifespan will depend on the installation. Was it dented? Is it scratched? Somebody went with a screw and
They put
put their name
dents.
on it.
They put dents when they come and inspect it, if you get a new fuel.
Yeah, yeah.
He hit it so hard with the hammer, I thought he was gonna go through it, he left like, it looked like an axe or something he used to hit the tank, just to make sure that it wasn't rusted. And he left like a long,
That should be a mallet.
long.
If you really want to, you use a rubber mallet to put things in.
uh,
So there's a lot of malpractice out there.
approximately 10 years.
10 years.
In the soil,
Huh?
in the soil.
No, that's above ground.
above.
And the soil you have to check with the manufacturer. And probably they will provide you with inspection details with that.
Mhm.
So pump. Let me do the. I'll wait one minute. I'll do the pump. So we learned about pumps before. How do we check pumps for leaks? You can check for pressure. You can do vacuum pressure or outside pressure. And we said we can pressurize the pump, turn it off, and the pressure should drop by how much? Remember.
Oh, 20, 50, is that?
15%.
15%.
I should stop there. If it keep dropping, that means there's a leak in the pump or in the line. So best way to check for pump leak is to check pressure. You can check the vacuum coming out of the inside for the suction of the pump, or the output of the pump. Check if for any leaks. Again, it's really good practice to go and follow the line coming from the tank all the way. It's not going to be buried. It should not be buried. It should have a guard on it. It's in the ground. If it's buried, it should be galvanized and sheathed so it will not rust with the cement. So check for that. Be aware of any grinding noises in the pump. So listen to the pump a little bit. If it's grinding, if it's kind of rattling, something is loose inside. And if you don't have an oil filter, it's a good idea to install an oil filter. And probably now you can process copper pipes. So you're gonna cut the pipe, shut off the valve, cut the pipe, drain the fluid, flare the end, put a wire nut, put a flare nut, and install a filter. So installing filter is very, very important because it will preserve your pump life to catch anything that's coming out of the tank, a piece of rust, sludge, or whatever you have in the tank, it will go through the pump first. If the pump is pulsating, if the pressure is pulsating, there's a clog. So when you put the pressure, look at the pressure when the pump is operating. It goes up and down, probably the filter is clogged. There's something that goes in and out a little bit inside the tank, inside the oil line, or could be the oil supply line, could be clogged. Pump must be positive displacement shut off, if not gas. So if we're not using gas, the pump should be positive displacement, which means it goes only in one direction. And this pump is able to pull oil in the line even if it's empty, as long as the tank is gravity level. So we saw that also last time when we bled the pump, and we saw the oil comes all the way up, even though the line is empty, as long as it's not much lower than the tank. So it can pull some vacuum, but not a lot. We'll talk about that so the book has a lot of good what-if scenarios. So that's why I want you to have the book. It has a lot of troubleshooting stories. What if this, check this, it has a lot of errors in it, and some kind of diagram to show you what could be possibly wrong with the system. So let's play the video.
From a selfish perspective, tank inspections make all. Proper inspection and maintenance extends the life of fuel oil tanks and reduces the number and severity of oil spills. Keeping oil in the tank where it belongs is good for everyone. From a selfish perspective, tank inspections make all of our jobs easier. After all, nobody enjoys cleaning up after an oil leak. By regularly inspecting tanks and correcting minor problems before they lead to major headaches, we can prevent catastrophic tank failures, eliminate the need for many emergency service calls, keep oil heat customers happier, and protect our environment. So, what really constitutes proper tank inspection and maintenance? The answer depends on the type of tank and its location. This video will demonstrate proper inspection procedures for the most common types of tanks and installations you're likely to encounter. There are 3 different types of inspections that NORA recommends for fuel oil storage tanks. The first is the initial inspection that should be performed before delivery is made to a new installed tank or to any tank belonging to a new customer. The purpose of this inspection is to be sure that the tank is in good shape and can be safely filled with little or no risk of spillage. This is also an important opportunity to look over the rest of the oil heat system to make sure the customer's equipment is up to date and capable of proper and efficient operation. This category includes all new customers' tanks, regardless of how long they've been in use. This initial inspection is especially important because customers often ignore recommendations for tank upgrades and simply keep calling until they find a company willing to deliver to their bad tank. Don't be that company. It's just as critical to inspect newly installed tanks to be sure that the installation meets applicable codes, and most important, to be sure that the installation is complete. We often hear about spills that occur because of a contractor forgetting to install the oil gauge, oil line, tank bottom valve. Occur because of a contractor.
See this, this is a copper line, and this is the covering around it. I don't know what was asking me that last week. So it looks like it's orange covering.
Forgetting to install the oil gauge, oil line, tank bottom valve, or other component. The second type of recommended assessment is the routine inspection that should be performed during a scheduled preventive maintenance visit or service call. This verifies that a tank that has passed the initial inspection can still be safely filled. Typically, the service technician who performs the routine inspection can repair any minor problems discovered. The third type of inspection, the pre-delivery inspection, is a brief visual check that should be completed each time an oil delivery is made. To make the critical job of conducting these three kinds of inspections easier and more precise, sample checklists of recommended inspection procedures are available in NORA's publication, Heating Oil Storage Tanks, Guide for Quality Installation and Maintenance. The initial inspection is the most comprehensive of the three types recommended by NORA. It is typically performed by a sales representative, service technician, or other qualified oil
This checklist actually in your book.
heat professional before a delivery is made to a new tank or to a new customer. Before starting the inspection, the customer should be asked about any out-of-service tanks on the property. If there are any, it's critical to verify that they have been properly abandoned and cannot be accidentally filled. Let's examine the process for an in-ground or buried tank first. The inspector starts by gathering some general information from the customer, such as the tank's age, type, and size. The customer may or may not know this information. If they do, it's noted on the form. The inspector should examine the fill location of the tank to be serviced and write an accurate description of the location so the oil driver will easily find the correct fill. The area around the fill must be carefully examined for any indication of oil spills, such as dead grass, dead bushes, and so forth. If there is any such evidence, it's important to note it on the form. The inspector should also make sure that the fill and vent are positioned to avoid a buildup of water or snow to prevent water from entering the tank. Next, the fill cap should be checked to be sure it's in good shape and properly tagged. Plain caps that don't specify what they are connected to should be avoided. These can be connected to wells, septic systems, and other places where we definitely do not want to pump oil. Then the fill pipe itself must be examined to verify that it's properly sized, in good shape, and made of the proper material. It's important to remember that neither copper nor PVC pipe is acceptable for fill or vent piping. It should also be verified that the fill terminates at least 2 feet from windows, doors, or other openings to a building. Next, the current level of oil in the tank and the presence of water must be checked. Water
So he's applying paste to stick the tank, the stick inside the tank, all the way down.
finding paste is applied to a tank measuring stick, which is inserted into the tank until it reaches the bottom. After 1 full minute, the stick is removed and the oil level and the depth of any water, as indicated by the paste, must be noted. Turning to the vent pipe, its size, condition, and location should be noted. The vent pipe should terminate higher than the fill pipe and be visible from the fill. Like the fill, the vent should terminate at least 2 feet from windows, doors, or other openings. Additionally, it should be at least 5 feet from any air inlets or flue gas outlets of any appliances.
So, it can be close to the door?
2 feet from any door, at least 2 feet, and 5 feet from any air intake.
What about like a dryer vent,
Probably it's gonna be 5 feet.
5 feet?
That's not the same as the NFPA 5 foot
Yeah.
from the opening, right?
The NFPA wants to have at least 5 feet.
For the one on the left?
Yeah.
Okay.
So an
But this is
opening,
hot, this is small. Yeah.
an opening doesn't include a door?
Huh?
That's what it looks like.
No, it's 5 feet from here. It's 2 feet from here,
Oh,
the minimum.
but 2 feet.
Yeah, and here is 5 feet from any intake or vent for like dryer and so on.
Remove the vent cap, verify that it's in good condition, and check that the mesh is in place to prevent insects from entering and building a nest. This completes the inspection at the tank. Check that everything is secured and back in its place before proceeding inside to continue the inspection. As we do every time we enter a home, the inspector should carefully check his shoes to ensure that he's not tracking in any dirt. Proceeding directly to the place where the oil lines enter the building, the following items should be checked. Verify the size of the oil line, typically 3/8 or 1/2 inch OD pipe, and note it on the inspection form.
So what is it, 3/8 and half an inch
Mhm.
filter?
Check that the oil lines are made of
That's the
Okay.
pyromatic valve.
approved material, such as copper or steel pipe, and that they are connected with the proper fittings. Copper pipe should be connected with flare fittings. Compression fittings should not be used. Steel pipe should be connected with malleable fittings. Cast iron fittings, which are used with steam systems, can be easily broken and must not be used when piping oil tanks. Check for a working supply line.
So either steel fittings or brass. No cast iron and no copper.
For the fuel line.
Yeah.
Shutoff valve at the wall, and make sure that any buried piping is protected from corrosion. Note on the form if it's a 1-pipe system with 1 oil line from the tank, or a 2-pipe system with a return line connected to the tank. Check to see if an oil safety valve is in place, and if so, that it's installed according to the manufacturer's instructions. Make sure that the oil lines are supported and properly connected from the entry point to the burner. Verify that there's a properly installed oil filter on the system and that fusible valves are properly located. Check that any other accessories that are part of the oil delivery system are properly installed, and ensure there are no visible leaks in any part of the system, from the entry point to the burner. The procedure for above-ground tanks differs somewhat from that for buried tanks. Since we can see above ground tanks, we are normally able to perform a more comprehensive inspection. Whether it's an indoor or outdoor above ground tank, the inspector again starts by gathering some general information from the customer. Pipe size and required clearances from building openings are the same for the fill and vent pipes on these tanks as they are for those of buried tanks. Check for evidence of spills and verify that the fill and vent pipes and caps are in good shape and positioned properly. Moving to the tank itself, carefully check for signs of leakage. Check the legs or supports. Verify that the tank is at least 6 inches off the ground.
That's something we haven't talked about. 6 inches from the ground.
The filter?
No, the whole tank.
Oh, whole tank, okay.
That way you
Check
can
the
properly inspect it for leakage.
Yeah.
Condition of the floor, or for an outdoor tank, the pad or foundation. Check that a tank gauge is installed and functions correctly. Measure the level of oil in the tank to verify the gauge reading and check for water. If the gauge or a plug is removed, it should be coated with an approved pipe joint compound and properly reconnected. Make sure any unused openings are properly plugged. Check for evidence of excessive external corrosion. And verify that the tank is at least 5 feet away from the burner or any source of fire or flame.
Got that? 5 feet from the burner, which
If
doesn't
it's
seem like
open
much.
to it.
Huh?
If it's open to it.
Yeah. Unless it's in that room.
So what if
Make sure the fill
What's it?
and vent pipe
Huh?
I said, so if there's a wall, a single rule applies?
Say that again?
If there was a wall that divided it, then a single rule applies?
If the wall is made of bricks, I think it will be okay. But if it's combustible material, then it's going to be the same rule.
are pitched toward the tank to prevent oil from being trapped. Also check that a vent alarm is installed and test it with either a vacuum cleaner or a CO2 charge. Verify that there is an oil shutoff valve at the tank and perform an oil line check as previously described. If the tank is located outside the building, verify that it is set back the required distance from property lines. Typically, a minimum of 5 feet for tanks up to 275 gallons and 10 feet for larger tanks up to 660 gallons.
Write this down. That's from the property line. So 5 feet for the small tanks, 275, and 10 feet at least from the property line if it's 660 gallons and if it's placed outside. So that's also important.
from a fence? you're saying?
Yeah, from your property line. Even if there is no fence. Okay.
Is required. Note whether or not the tank is installed in a protective enclosure. Verify that any outside oil lines are correctly insulated. Also explain the tanks exposed to direct sunlight should be painted a light color.
So in the summertime, if there's some oil, the stock color is going to be really hot, and you might reach the flash point. So light color is very important in the outside, and also for the small little oil lines, it's gonna be 3/8 or a half. It's easy for it to freeze, so it's good to insulate that.
Which color is the one recommended? A solid white?
Yeah.
What about if it's like a bright red? It's more
Like I say,
recommended to be
white
white.
for outside, yeah.
It's just a recommendation,
Yeah,
not
yeah.
most of them
Such as
in mass
what?
are black
Yeah, but
outside.
they make it black in mass because they assume you're gonna fill the tank only in the winter time, and if it's dark color to absorb whatever heat is there and keep the oil running. That's the rationale behind
To
it.
minimize water buildup due to condensation. Note whether or not the tank is installed with the full secondary containment. Make sure the tank is properly secured if the area is prone to flooding. Now that the initial inspection has been completed, the inspector should write any comments on the inspection form and qualify the tank into one of three categories. The first category is acceptable for delivery, meaning that the tank appears to be in good shape and there are no apparent serious deficiencies which require attention. For example, a small amount of external corrosion is normally acceptable. But the customer should be advised that the tank is their responsibility. It should be painted periodically, and if they notice problems or oil smells, they should call their oil company immediately. The second category is acceptable for delivery after listed deficiencies are corrected, meaning that there are discrepancies which must be corrected before a delivery can be safely made. For example, the tank may be sitting on an unstable foundation and may tip over if filled. The final category is not acceptable for delivery. Tank must be replaced, meaning that the tank is in such poor shape that it is either impossible or impractical to repair it. An example might be a tank which has a leak covered with a magnet patch.
I have a
Question,
question, I'll ask later.
but it does happen.
But what if like, the oil goes through the patch?
Well, I don't know, but if it's leaking, you cannot deliver oil to it. And that's in the bottom, it's a lot of pressure.
So I'm saying, so it wouldn't affect the magnet?
Routine inspections do not have to be as comprehensive as initial inspections, but should be an integral part of every heating system tune-up. By performing these inspections on tanks that have passed the initial inspection, we are often able to detect and correct minor problems that could cause major damage if they aren't discovered. During a routine inspection, you should measure the level of oil in the tank. Check for water in the tank. Check the tank gauge. Make sure the tank is 5 feet away from the burner or other sources of flame. Although this was verified during the initial inspection, the customer may have had a water heater, dryer, or other fuel-fired appliance installed after the initial inspection was performed. Look for evidence of spills or leaks. Check the fill and vent pipes and caps and make sure that they are still positioned to avoid a buildup of water and snow. Check that the vent is free of obstructions. Check that the oil shutoff valves function properly. Make sure the oil lines are properly connected and verify that outside oil lines are insulated. And finally, check the entire system for visible leaks, from the fill all the way to the burner. Once the inspection has been completed, the inspector notes whether or not the tank is still acceptable for delivery. If minor corrections are necessary, the service technician normally advises the customer of the problem and the investment required to correct it. In many cases, the defects can be quickly and inexpensively fixed. As with the initial inspection, any non-essential repairs, such as painting, are noted on the inspection form. The initial and routine inspections should be documented. NORA provides sample forms in the book Heating Oil Storage Tanks, Guide for Quality Installation and Maintenance.
That's good. Did you recap?
Mr. Khan, in Mass, can an oil burner tech install the vents, the fills, and the fuel lines?
No.
What can an oil burner tech do?
You install a burner, the oil lines from the tank.
The oil lines from the tank to
Yeah.
the burner?
Yeah,
But not the fill and vent?
no, that has to be a pipe filler. Also double check, that's what I know so far. Okay, from the video, the summary, the tank is the responsibility of the owner. It's not your responsibility, so you should note stuff if you don't want to deliver, then, and you find it's not acceptable, you should tell them that it's their responsibility to maintain it, the painting, the dents on it, they should fix that. This is from the outside above ground tank, the property line is 5 feet for up to 275 gallons, and 10 feet to for between 275 to 660 is 10 feet at field. 2 feet from the property line. Do not deliver to a bad tank if there's a leak, if you find it's uneven. And what is the standard and the required base for the tank? Concrete. Even if it's outside, you have to put a concrete platform. If it's uneven, do not deliver to that tank. If it's able to topple, don't deliver to that tank. This has to be wet painted white, but some kind of paint that will resist the heat and condensation. Vent and fill pipe has to be high enough to prevent snow and water accumulation. So if you have the vent around like 6 inches from the ground, it's gonna be covered in snow. So you're gonna go and have to search for that. So put it at least 2 feet from above ground so you can find it. And it's good to have a different color so you can find it when it snows. Vent pipe is higher than the supply pipe. Both vent pipes and supply pipe should be pitched toward the tank, so you don't have any stagnant oil. Tank has to be at least 6 inches from the ground. Cap should be checked for mesh to prevent insects from getting inside the product. Just put a mesh inside the pipe so things do not fall into it. Use color finding paste to discover water in the bottom of the tank. All right. That's what we have for this week. So tank, and this is chapter 3. We'll keep going through these things. I will try. It's a good idea to print out the CMR. I'll try to see if I can get it printed out for you. Otherwise, we just have to print and don't try to search for it online. It's the same one. They have changed it.